Hello everyone, I'm Shivani and welcome to Civil Series. So this video is about the short notes of theory of structure, and this theory of structure is fully based on BMC syllabus of sub-engineer and junior engineer. So in this video we'll cover each and every important point from theory of structure as per the short notes. So let's start with the video first. So first we start with the syllabus. So in the theory of structure, analysis of beam is there, analysis of beam, frame and trusses. Then slope deflection method and moment distribution method. These are the two methods in the theory of structure. Okay. So first we start with the classification of structure. Classification of structure is divided into two types. First is on the basis of dimension and second is on the basis of joint. So we'll see first on the basis of dimension. Okay, so you all know there are two type of dimension, 2D and 3D. Okay, there are two type of dimensions, 2D and 3D. So first we go with a 2D structure. First we go with a 2D structure. 2D structure is also known as plane structure. 2D structure is also known as plane structure. In case of 2D structure, there are three unknowns. Okay, there are total number of unknowns in 2D structure are 3, and in that 3, 2 are linear unknowns. 2 are linear unknowns. Linear forces are 2. Okay, and angular force is 1. Angular force is 1. So which are the linear forces and which are the angular forces? So linear forces are f of x and f of y, and angular force is movement. Okay. Similar in case of 3D structure. So 3D structure is also known as the space structure. Okay. 2D plane structure and 3D as a space structure. In case of a 3D, total number of unknowns are 6. Total number of unknowns are 6 and the linear force is 3 and angular force is 3. Okay, so here linear forces are f of x, f of y and f of z. Then similarly m of x means movement, m of y, m of z. So these are the linear and angular forces in case of 3D structure on the basis of dimension 2D and 3D. 2D known as a plane structure, 3D known as a space structure. 2D consists of 3 unknowns, 3D consists of 6 unknowns. In 2D linear are 2, angular is 1, and in case of 3D linear are 3, angular are 3. Then second, on the basis of joint. On the basis of joint there are 4 structures or 4 structures. In that first is simply supported structure. Simply supported structure. Then second is pin jointed structure. So pin jointed structure also known as trusses or truss structure. Then third is rigid jointed structure. Rigid jointed structure is a frame structure. Rigid jointed structure is a frame structure, and last one is grid structure. Grid structure. So these are the 4 structures which are classified on the basis of joints. So in that first is simply supported, second one is pin jointed structure or truss, and third one is rigid jointed structure and frame structure, and last is grid structure. Okay, then next point is type of support for 2D and 3D structure. Okay, so there are 4 type of supports. First we see it for a 2D structure. So for 2D structure, first support is guided roller support. Guided roller support. So guided roller support is, so this is the guided roller support. First, the guided roller support is in a vertical direction, called it as a vertical guided roller support, and second one is in horizontal direction, and this is known as a horizontal guided roller support. Okay, so this is vertical guided roller support, and then second is horizontal guided roller support. So this vertical guided roller support example is shutter. Okay, shutter of stores. So this is the example of vertical guided roller support, and this support is allowed to move in a vertical direction. Okay, means that vertical value is not present here. Okay, because it is allowed here. And horizontal and movement, there is restriction for these two values, so these values are present here. So this is the kind of reactions act on this vertical guided roller support. Then in case of horizontal, this horizontal guided roller support example is gate. Okay, that gate is present on entrance of our house. That kind of a gate is horizontal guided roller support, is with horizontal guided roller support. And this gate has, or this support has, only horizontal direction movement. Okay, it move only in a horizontal direction. That's why the horizontal value, horizontal force value is not present here, but the vertical and movement value is present here, means it is prevented in a vertical and movement. Okay, so these are the values for guided roller support. Then next supports are roller support. So roller support is, this is how we represent the roller support. So this roller support is with a vertical force. Okay, so here vertical force is present, means this roller support is not allowed to move in a vertical direction, means for the vertical the value is present, and for horizontal and movement values are not present. Okay, then next third is hinge support. Hinge support, so this is the hinge support. This hinge support is with a vertical force and horizontal force, means the value of vertical and horizontal, both the values are present here and movement is not present here. Then fourth, fixed support. So fixed support, so this is how we represent the fixed support: horizontal, vertical and movement. Here horizontal, vertical and movement, all the three values are present, means this fixed support is restricted in all the three direction, or all the two directions and movement, the restricted in case of a fixed support. So these are the values for 2D structure. Then we'll see for a 3D structure. Okay, then in case of a 3D structure, so this is how the 3D diagram. Okay, so here x, y and z, hx, hy and hz, these are the movements here, mx, my and mz. Okay, so first guided roller support. First is guided roller support. First is vertical guided roller support and second is horizontal guided roller support. Vertical guided roller support is allowed to move in a hx, hy, mx, my and mz. These are the values which are not allowed, or these are the values which are prevented in case of a horizontal guided roller support, means values are present here. And that allowed in case of a Vy. So here correct it Vy. Okay. Then in case of a horizontal guided roller support, these values are allowed in case of Hz, Vy, then Mx, My and Mz. Okay. Here values are present, and values which is not present here is Hx, is allowed in that direction. Then second, in case of roller support, this roller support is only restricted in case of a vertical direction, in case of vertical direction movement. So that's why Vy is present here, and the remaining values which are Hx, Hz, Mx, My, Mz all are not present here. Then third is hinge support. Hinge support is allowed to movement only in case of a movement, and it is restricted in a horizontal and vertical forces. So here the values of Hx and Vy are, and the one more value which is Hz is also present here, and remaining Mx, My, Mz values are not present here. Then last one is fixed support. So in case of fixed support, the all values are restricted here. All movements, all forces are restricted. So that's why all the values are present. mx, my and mz. Okay, these all values are present here. Okay, here one thing is important, that remember, if in case of any support there is a allow of any direction, there is allowment of any direction movement, okay, then the value is absent there. Okay, because there is a no restriction as a value. And if there is a restriction of any kind of force on any kind of support, then that value, value of that force is present there. Like in case of roller support, Vy direction movement means vertical movement is not allowed, means there is a one value which is not equal to 0. That's why I correct it as or take it as correct, because this value is present. But in case of hx, hz, mx, my and mz, values are not present. Means these values are equal to 0. Okay, these values are equal to 0. That's why this roller support is allowed to move in these kind of directions. Okay, so this is how the concept here, and these are the 2D and 3D structures, and with their forces and movements. Then determinacy and indeterminacy. Okay, so before discussing this, first we discuss about the static equilibrium equation. Equilibrium equation. Okay, so there are three equations: f of x equal to 0, summation of f of y equal to 0, and summation of moment equal to 0. Okay, so here first determinacy, second is indeterminacy. If any kind of beam, truss and frame is solved by the help of these static equilibrium equations, then that structure is known as determinacy. Means solved by summation of f of x, summation of f of y and summation of moment. And here not solved by, not fully solved by. Okay, some few values are solved by these equations, but some values are remain to solve, then this is considered under the indeterminacy. Okay, then there are few examples related to determinacy. First is three hinged arch. Second is simply supported beam or simply supported structure. Then third is overhanging beam, and last one is cantilever beam. Okay, these are the examples for the determinate structure. Then the examples for indeterminate structure. First is two hinged arch. Then second is fixed arch. Second is fixed arch. Then third is redundant arch. Then fourth is fixed beam. Fourth is fixed beam. And then next fifth is continuous beam. And next is sixth number propped cantilever beam. Okay, so these are the few examples which are related to determinate and indeterminate structure. Okay, and here in the exam they ask about the 3 hinge arch and 2 hinge arch, because these examples are confused that which is determinate and which is indeterminate. So that's why these two are important. Mark it as important. Okay, two hinge arch is under the indeterminacy and 3 hinge arch is under the determinacy. Okay, the next point. Then next, on the basis of indeterminacy, there are two types. First one is static indeterminacy and second is kinematic indeterminacy. Static indeterminacy is represented like this, ds, and kinematic indeterminacy is represented like dk. Okay, then static indeterminacy is divided into two types. First one is external static indeterminacy and second is internal static indeterminacy. Okay, first is external, second one is internal. So ds is external static indeterminacy plus internal static indeterminacy. Okay, addition of these two is nothing but a static indeterminacy. External static indeterminacy is represented by ESE or DSE, and internal static indeterminacy is represented as DSI. So here DS is equals to DSE plus DSI. This is the formula for static indeterminacy. Okay, and we'll see the static indeterminacy and kinematic indeterminacy in detail in further video. Then next is external static indeterminacy. So this is the part of static indeterminacy. One part is external static indeterminacy and second part is internal static indeterminacy. In that first, external static indeterminacy is represented like this, that DSE. So formula for DSE is DSE is equal to RE minus 3 for 2D structure and DSE is equal to RE minus 6 for 3D structure. Okay, so here the RE is total number of unknown reactions. Total number of unknown reaction is equal to RE, and then if the value of DSE is greater than 0, okay, if you calculate this and you get the value of DSE greater than 0, then that structure is externally indeterminate. Externally indeterminate. And same in case when DSE is less than or equal to 0, then that structure is externally determinate structure. Okay, externally determinate structure. Okay, so formula is DSE is equal to RE minus 3 for 2D and RE minus 6 for 3D. RE, from where you calculate that RE? So for example, this is the simply supported beam. Okay, and this simply supported beam, here for this simply supported beam is 2D. Okay, to calculate the DSE of this beam, so DSE, here the reactions are 1 second, and here one more reaction, here horizontal reaction is there, so 3 reactions are there. Okay, so 3 minus 3 equal to 0 for this particular example. 3 minus 3 equal to 0, so here the value is equal to 0. So here this condition is happens, means this structure, this simply supported beam structure is externally determinate structure. Okay, that's how you calculate the DSE. Okay, then next there are some special condition in case of external determinacy. So that cases are, first case is if there is any fixed beam. Okay, if there is any fixed beam and that fixed beam is acted by a point load, and because of that point load, the here on this beam only vertical reactions are acted. So because of that vertical reaction there is a no horizontal reaction. So you can take the value of DSE as here as replace this 3 with 2 because only 2 equilibrium conditions are required here. Okay, if you calculate by this formula then you get a same value, but this is the condition when there is any point load, you take 2 as the unknown equilibrium equations or two number of equilibrium equations, and the total number of unknown reactions are here. Here horizontal, you neglect the horizontal here, so that's why 2 from this side, 2 from this side, so get 4. So this is equal to 2. Okay, so if fixed beam is subjected to point load, then that beam or that beam is externally indeterminate, externally indeterminate by 2 degree. Okay, and same if the fixed beam, is subjected to incline loading, subjected to incline loading or no loading, then that beam is externally indeterminate by 3 degree. Okay, these are the two MCQs which asked in an exam, so these two are important. If fixed beam is subjected to point load, then that beam is externally indeterminate by 2 degree, and if fixed beam is subjected to incline loading or no loading, then that beam is externally indeterminate by 3 degree. Okay, here indeterminate by 3 degree. Then next internal static indeterminacy, that represented by DSI. Okay, so there are two formulas for DSI. DSI is equal to 3C minus RR, and DSI is equal to 6C minus RR. This is for 2D structure and this formula is for 3D structure. Okay, so here C is number of closed loop. Number of closed loop. Okay, you can change this C as C dash, and that C dash is a number of cut. Number of cut required to make structure close to open. Okay, here C and C dash are equal. Okay, for example, you take example here. So this is the frame. Okay, this is one of the frame, and this is the closed loop. Okay, so here take C as 1 because this is a one closed loop. Okay, and C dash is number of cut required to make the structure close to open. Okay, if you cut this line, then you get a open loop. Okay, so that's why C dash is equal to 1 because one cut is required. So here C is equal to C dash. You can take C here or C dash here. The value or the last answer is same. Okay, then RR is the internal releases. RR is the internal releases present in a structure. Okay, we'll discuss that internal releases in the video further. And then next, the same this condition. Okay, mainly this condition is for beam or frame. Okay, this condition is for beam or frame. Okay, here I write RR is equals to internal releases. Internal releases. Then next conditions are for trusses and pin jointed structure. Okay, this condition is about the beam and frame. Next condition is about the trusses or truss structure or pin jointed structure. Pin jointed structure. And formulas for that are DSI is equal to M plus 3 minus 2J, and second DSI is equals to M plus 6 minus 3J. This is for 2D and this formula is for 3D. Okay, M is the member, J is equal to joint, and both are formulas for 2D and 3D structure. Okay, these formulas are for truss and pin jointed structure. These formulas are for beam and frame structure. Then some important points. Okay, these are four formulas which are important. If you solve any kind of a numerical, and if you want to solve that numerical directly, okay, to decide whether that structure is determinate and indeterminate, statically determinate or indeterminate, so you can use these formulas also. So for pin jointed structure, for pin jointed plane structure, for pin jointed plane structure to be statically determinate. Okay, if the structure is statically determinate, means ds is equal to 0, you can directly use this formula. M plus r minus 2j equal to 0, 2d, and m plus r minus 3j equal to 0 for 3d. Both the formulas are for truss or pin jointed structure. Truss or pin jointed structure. Then next, 3m plus r minus 3j equal to 0 and 6m plus r minus 6j equal to 0. This is for 2D and this is for 3D. Both formulas are for rigid frame. For rigid frame. Okay. Then next important thing is two names for there is another name for indeterminate and determinate structure. Indeterminate is also known as hyperstatic. Hyperstatic. Okay, indeterminate is also known as hyperstatic, and then determinate is known as hypostatic. Okay, these are few important points. The next point is next is internal release in static indeterminacy. Okay, so you all know that RR is the internal release as we seen in the formula of internal static indeterminacy. So internal release is RR. So first for internal hinge, so this is how we represent the internal hinge. This is the beam and this is the internal hinge. Okay, so this is the internal hinge, and RR value for internal hinge is equal to 1. Then next for internal roller, so this is the internal roller. This is the internal roller, and value of RR is equal to 2. Then next internal horizontal guided roller. So this is the internal horizontal guided roller, and RR value is here, RR equal to 1. Okay, RR is equal to 1. Then next internal vertical guided roller. So this is the internal vertical guided roller, and value of RR here is also equal to 1. RR is equal to 1. Then the internal horizontal guided release is also known as axial release. And internal vertical guided roller is also known as shear release. Okay, then next and last, which is very important, that internal hinge provided at joint or at junction. So this is the junction which is present in any kind of frame and truss. So this is the junction present in the frame, and here on this junction, three members are meet. Okay, so M dash is equals to number of member meeting at internal hinge. So this is the M dash, and formula to calculate the internal release for this is RR is equals to M dash minus 1. Okay, so here for this junction M dash is equal to 3 and RR is equals to 3 minus 1 equal to 2. Okay, so this is how the internal release in static indeterminacy. Okay, so we completed the portion of static indeterminacy here, and in the next video we see about the kinematic indeterminacy and a few more important points related to theory of structure. And till now this video is up to the static indeterminacy, and stay connected for further points, and thank you for watching.